Hello Math 10, welcome back. Today we're going to continue word problems with trigonometry. So before we just looked at simple triangles, now we're going to look at double triangles. So it's kind of like seeing double, just like Donald Duck here in that picture. Now, in this diagram, we have QS is equal to 32 millimeters. So QS is 32 millimeters, okay? PQS is 50 degrees. So P to Q to S is 50 degrees. So that there is 50 degrees. And we also know that angle RPS, so we go RPS, is going to be equivalent to 61. Okay? Use this information to determine the length of QR. So we want the length of Q all the way to R. We want this whole distance here. That's what we're trying to figure out. So let's first maybe try and figure out, we have to figure out this RS. But in order to do that, I need to know one side of this triangle here. So how am I going to do that? Is I'm going to find PS using this triangle here. Okay? Well, if I look at side PS, that is the opposite of the angle. I also know the adjacent of the angle. So in this case, we're going to use tan. So tan 50 is equal to opposite over adjacent. So this is PS over my adjacent, which is 32. So I put this in my calculator. I have 32 tan 50 will be equal to PS, which is equal to, first thing I must do is once again make sure my mode is in degrees. It's in radians there, so I must switch it quickly to degrees. Okay, so I'm going to clear it. And I have 32, and I want tan 50. That's going to give me 38.1. So I have 38.1, and that's going to be millimeters, is equal to PS. So I know this is 38.1. Well, I am going to, so I always have this angle, store this as X. So I'm going to show you right here. I'm going to hit this store button just above, right there, and I'm going to then hit the X button. So we're going to have something that looks like that on your screen, and so now that's always going to be X. Okay? Now, I know this side and I know that angle. And once again, I want to find the opposite. And I know the adjacent, so I want to find the side opposite of that angle to the adjacent. So I'm going to have now tan 61 is equal to opposite over adjacent. So that's going to be RS all over 38.1. Okay? So I rearrange this. RS is equal to 38.1 multiplied by tan 61. So in this case, I'm just going to put X. So I'm going to multiply that by tan of 61. And I end up getting 68.8. Okay? So I look at this now. This is 68.8. And my whole distance is going to have to be 68.8 plus 32. So if I add those, 68.8 millimeters plus 32 millimeters, and 1 to the nearest millimeter, so that's really 69. This is going to give me 101 millimeters. Okay? Now let's take a look at my next triangle. It says, calculate the measure of angle BEC to the nearest degree. So we want BEC. So we're trying to figure out this angle here to the nearest degree. Now looking at this again, I don't know enough of this triangle to solve it. But looking at this triangle, I know one side and an angle. So I could use this triangle to help me solve and get this side, and then solve for the rest of that triangle. And I know a side of this triangle. Okay? Or I know two sides then. So I could use my trig identity. So here we go. I have an angle, and I want to find the opposite, but this time I'm knowing the hypotenuse. So what are we going to use? We're going to use sine. So sine 39 is equal to my opposite, which is EC, over my hypotenuse, which is 3.7. Okay? So I'm going to rearrange this. I'm going to end up getting and I'm going to plug that into my calculator. So I have 3.7, and then I'm going to sine and 39, and I'm going to end up getting 2.3. Okay, so we have 2.3 meters. So we know that's 2.3. Now we want to find this angle here. And I know the adjacent and I know the hypotenuse. So if we're looking at adjacent and hypotenuse, what are we going to be doing? Cosine. So we want cosine of x is equal to, well, adjacent, which is 2.3, all over my hypotenuse of 4.6. We're trying to solve for x here, so I'm going to have to go the inverse of it. So I have x of inverse of cosine. So I have x is equal to cosine to the -1, 2.3 all over 4.6. Okay? So let's plug that into my calculator. So if you remember, I'm going to hit the second button, and then I'm going to hit cosine. Okay? Just like that. So I get that, and I want 2.3 divided by 4.6. Close my bracket, and I end up getting 60 degrees. So I end up getting x is equal to 60 degrees. So here we're looking at our next question. In January 2003, the tallest building in Rockyville was the Metro building. Recently, a developer was commissioned by GammaPro Oil Company to build a taller building next to the Metro building. From the top of the Metro building, the angle of elevation to the top of the GammaPro building is 24 degrees. So right here, my angle of elevation, so we go from straight across up, is going to be 24 degrees. Okay? And the angle of depression to the foot of the GammaPro is 56. So this must be my GammaPro, and this is my Metro. Okay? So the angle of depression here is going to be 56. Alright? Now, we also know that the buildings are 45 meters apart. So the buildings here are going to be 45 meters apart. Okay? So this is my angle of depression. So then this angle here is going to be 56 as well. And this distance here is going to be 45. Okay? So they're 45 meters apart. Now, if the buildings are 45 meters apart, we want to determine the height of each building to the nearest meter. So I want to determine the height of this one, which will be this value, and I want to determine the height of this one here, which is this plus this. Okay? So let's start off here. I know this is 56, I know this is 45. So I'm going to find out first the height of the Metro building, which is going to be this distance here. Well, I know 45, I know the adjacent, and I want to find the opposite. So I'm going to say Metro, the height of the Metro is this here. So 56, 45, same thing. And I want to find the opposite, so, and we know the adjacent, we're going to have to use tan. So tan 56 is equal to, or we can use this one here, because this is going to be the same height as the Metro, is equal to opposite, which is the Metro, all over my adjacent, which is 45. Okay? So I have 45 tangent of 56 is equal to the Metro height. So I'm going to plug that into my calculator. I have 45, and I'm going to put tangent of the Metro, which is 56. And I'm going to end up getting 66.7. So that is 67 meters. Okay, so I have 67 meters is my Metro. Now, we want to find the height of the GammaPro. So I need to first find this little bit here. Okay? Now, once again, we know the adjacent, we want to find the opposite. So I'm going to use tangent. So tan 24, because we're looking at this angle, and we're on the opposite, is equal to my top. So we're going to have, I'm going to put this as y all over 45, my adjacent. So I have 45 tan 24 is equal to y. Let's plug that in. So we want to plug in here 45 tangent of 24, and I'm going to get 20, which is equal to 20. Now, I know the height of the gamma is equal to, well, the height of the metro plus my y, which is going to give me, we have 67 plus 20, which is essentially equal to 87 meters. Okay? So we know my two heights are 87 and 67 meters. Okay? Alright. Now, here we're looking at a 3D object, which might make it a little bit more complicated. It says the solid in the diagram is a rectangular prism by removing a wedge. Okay? So right here we say HD is equal to GC, which is equal to 5 centimeters. So I'm just going to first, because it's not quite labeled here, label everything. We have H, G, D, C, E, A, B, and F. Okay? So we have HD is equal to GC, which is 5 centimeters. So HD and GC is 5. Tick there, so those are the same. Now we know FB is equal to 2 centimeters, and EA are equal. So these two are equal, and they are 2 centimeters. Okay? I also know that AD is 6 centimeters, and AB is 8 centimeters. So AD is 6 centimeters, and AB is 8 centimeters. Okay? Now, it says, name 4 rectangles in the diagram. What are my 4 rectangles? I have G, H, E, F, okay? So, or E, F, H, G. Okay, there's one. I also have on the bottom A, B, C, D. Okay, and I also have right here EA and FB. And at the back I have HD, GC. Okay, so now it wants us to find the angle of HEA. So we want HEA. So I'm going to draw that side view out. It kind of looks like this. Okay, so we have H here, we have E here, and we have A there. Now in order to do this, I'm going to have to separate this. I know this is 2, this is 5. Okay? So then this remaining height here is going to have to be 3. Because if from here to here is 2, that means this is 3. Now I also know that this is 6 centimeters, so this must be 6 centimeters as well. Now looking at that, I could find out this angle here. This is going to be a right angle, and now I can find out that angle there. Okay? So, how do I find that out? I know my opposite and adjacent, so I'm going to use tan. So tan, angle E, is equal to opposite, which is 3, over adjacent, which is 6. So I'm going to have tan 0.5. So let's put that in. So we have E is equal to the inverse of tan to the 1 over 2. So I'm going to punch that into my calculator. So I'm going to hit on second tan 0.5, which is 1 over 2. So I'm going to get 26 degrees. So I have 26 degrees. But now I must add that to this 90 degrees. This is 26 degrees plus 90, so that's going to give me 116 degrees. Okay? Oh, 26.5, so 117. So it's 26.5. So it's 117 degrees. So now we're going to look at C. And C says we want to calculate the measure of angle HFE to the nearest degree. Okay, so here we go. I look at H, F, and E. So we have H, we have F, and E. So we want to go like this, from here to here to there. Okay? Now looking at this, let's draw that out. We have, okay, so it goes H, G, and we're going to end up having E and F. Okay? I want to find HFE, so I want to find that angle there. I know from my diagram that this is 8. This is 8 centimeters. I do not know this though. Okay? But I could find that given my last question. Going back to this question over here now, I know HE and I can find that HE because this is 3 and this is 6. So I could find this HE through Pythagorean theorem. So I'm going to try that out. We're going to find HE through Pythagorean theorem using that. So we had 6 and 3. So I know 6 squared, C squared is equal to A squared plus B squared. So I have 6 squared plus 3 squared is equal to 36 plus 9. Okay, we add those up. I'm going to get 45. We want to square root that. Alright? Now, this is going to give me approximately 6.7. Okay? Now, what do we want to do is we have this here. I know this, and now I know this opposite, which is 6.7. So we're going to have to use tan, because I know the adjacent and the opposite. So, tan angle, I'm going to call this x, is equal to, we're going to have 6.7, or opposite, 6.7 all over 8. Now we're going to have x is equal to the inverse of tan, to negative 1. And 6.7 is really, if I want exact, it's going to be square root 45. Just to keep a more accurate answer all over 8. Okay? So I'm going to plug that into my calculator. And I'm going to end up getting, put in second tan, oops, it's on here, second tan, and I want the square root of 45, and then I want to divide that by 8, and I put it in brackets, and I end up getting 39 or 40 degrees. Okay? So we get 40 degrees as my answer. So hopefully you understood everything. Good luck, as I see you tomorrow.